In software development, a logger is a fundamental tool that helps us record events happening inside an application. Think of it as a detailed diary or a ship's logbook for your code. We instruct the program to write down important information as it executes. These are called log messages. They range from a simple notification that a process has started to a critical error that caused a system failure. Logs give a window into the application's internal state, behavior, and health, invaluable for developers and system administrators. Without logging, we'd be flying blind. The primary purpose of logging is to create a persistent, ordered record of application events. On a production server where you can't attach a debugger, logs become your primary source of truth. They help you trace execution flow, understand how data is processed, and identify the sequence of events that led to an outcome. This history is crucial for debugging after issues occur. Consult the log files for a step-by-step account, making troubleshooting far more efficient and less stressful. Imagine a complex app with hundreds of interacting components. Reproducing a reported bug can be incredibly difficult. A good logging strategy shows what the app was doing at the time. You might find log messages showing the user's input, the specific database query executed, or the response received from an external service. That context lets you pinpoint the root cause without replicating exact conditions. Logging turns debugging into methodical investigation. Logging isn't just for fixing errors, it also supports monitoring and auditing. Admins use logs to monitor health and performance in real time. They set alerts for error patterns and track KPIs like response times or transaction volumes. For sensitive or financial apps, logs are an essential audit trail. They record who did what and when. This is often required for compliance and security. Logging is a cornerstone of robust, transparent, secure systems. Spring Boot applications, which are often designed as microservices or complex monolithic systems, rely heavily on effective logging. The framework itself is built with logging in mind, providing a seamless, out-of-the-box experience. By default, Spring Boot uses Logback for logging, Log4j2, Java util logging. This built-in support means that as a developer, you don't need to spend time on complex configuration just to get started. You can begin logging important information from day one. Logging becomes an integral part of the development lifecycle, not an afterthought. In a distributed environment, such as one composed of multiple microservices, logging is not just important, it is absolutely essential for survival. When a single user request travels through several different services, pinpointing where a problem occurred can feel like searching for a needle in a haystack. This is where centralized logging comes into play. Each Spring Boot microservice generates its own logs, collected and aggregated into a central system like Elasticsearch, Logstash, Kibana, or Splunk. Adding a logger to a Spring Boot class is a straightforward and standardized process. The most common approach is to use the simple logging facade for Java, or SLF4J, which is the abstraction layer Spring Boot uses by default. To get a logger instance, you simply declare a private static and final field in your class. The logger factory class from SLF4J provides a static method called getLogger, which you use to obtain a logger instance associated with the current class. Passing your class name .class as an argument is a common convention, as it ensures that the log messages will be tagged with the fully qualified name of the class where they originated. Let's look at a concrete code example. Suppose you have a service class called user_service. To add a logger to this class, you would add the following line of code at the top of your class definition. This single line is all the setup you need within your Java code. You don't need to add any new dependencies to your pom.xml or build.gradle for basic logging, because Spring Boot Starter Web and other common starters already include Spring Boot Starter Logging, which pulls in SLF4J and Logback. Once you have the logger instance, you can start using it within your methods to record events. The logger interface provides several methods corresponding to different logging levels, such as info warn error debug. To write a log message, you simply call the appropriate method on your logger instance and pass the message as a string. For example, if you have a method to create a new user, you might want to log an informational message upon successful creation. This provides a clear record in the logs that a new user was added to the system, which is useful for tracking and auditing purposes. To make your log messages more dynamic and informative, it is a best practice to use parameterized logging. Instead of concatenating strings using the plus operator, which is inefficient, SLF4J allows you to use curly brace placeholders in your log message. You then pass the actual values as additional arguments to the logging method, For instance, to log the ID of a newly created user, you would write logger info, new user created with ID, user ID. This approach is more performant because the string formatting only occurs if the log message is actually going to be written, which depends on the configured logging level. It also results in cleaner and more readable code. So, to really make your logs work for you, it's super important to stick to some best practices. First off, always write log messages that actually mean something and include context. Error, data saved, doesn't help anyone. Instead, give some details. Who did what data was involved, what happened as a result. Example, logger to info, user, username, successfully updated profile information. That way, you know exactly what went down and who was involved. It's also key to include relevant IDs, like user IDs, transaction IDs, order IDs. This is especially important if you're working with microservices since a single request might pass through a bunch of different systems. Another big thing is using the right logging level for each message. You'll either drown in useless noise or miss out on critical alerts. Use info for major business events, debug for detailed technical stuff that helps with troubleshooting, warn for problems that don't stop the app. Example, failed connection to a backup service, error only for serious failures that actually break something. Keeping these levels straight helps you filter your logs way more effectively in production. Now you also gotta be super careful about logging sensitive information. Log files are often easier to access than your database and they might not be locked down as tightly. Never log personally identifiable info passwords, credit card numbers, API keys, or any other secret stuff in plain text. That's just asking for trouble and could even get you in hot water with data protection laws like GDPR. If you need to log something that might have sensitive data, try writing a custom two-string method that hides or skips those fields, or use a logging feature that filters out sensitive patterns before they hit your log files. Lastly, structure your logs so machines can read them easily. Human-readable logs are nice, but in modern setups, logs are usually crunched by machines. Using a structured format like JSON makes your logs way easier to search, parse, and analyze. Instead of just a plain text line, every log event becomes a JSON object with key value pairs for the timestamp log level message, and any other context like user ID or trace ID. Tons of logging libraries like Logback can be set up to spit out logs in JSON. This makes it way easier to search your logs in systems like Elasticsearch and build powerful dashboards and alerts based on your log data. Moreover, logging in Spring Boot helps us understand the framework's own behavior. Spring Boot performs a lot of magic behind the scenes, such as auto-configuration, dependency injection,